Imagine that we are doing an experiment now. This tool lead is connecting to an external power supply. This supply provides the forward biasing voltage for the PN junction diode. This supply, this resistor, this PN junction diode, this current meter are all connected in series. The voltage of the external supply is measured by this meter. The reading is labeled as V bias. It means forward biasing voltage for the diode. And then the voltage across the PN junction diode is measured by this voltmeter. The reading is labeled as VF, means forward bias voltage across the diode. For the forward bias current through the diode is measured by this current meter. The reading is labeled as IF. Initially, the power supply is set to 0, means the forward biasing voltage is 0. And under this situation, the forward bias voltage across the diode must be 0 volt, and the current go through the diode must be 0 current. Continue our experiment. We increase the forward biasing voltage. Set the external power supply, let's say to be quite a large value, 12 volt. And the voltage across the PN junction diode will measure to be only 0.7 volt. So you put down VF equals 0.7 volt. While the current through the diode could be quite a large value because the diode is now forward biased. This current will be in unit of milliamp still. Continue the this is the VI characteristic curve of the forward biased diode, a silicon diode. The x-axis is VF, forward biased voltage across the diode. The y-axis is IF, means forward bias current through the diode. Initially, the forward biasing voltage is at 0 volt, so the VF have to be 0 volt, and the IF has to be 0 milliampere. The forward biasing voltage is increased gradually from 0 volt to 0.7 volt. According to this VI characteristic curve, the forward current increases slightly. It will increase rapidly when the forward biasing voltage is increased beyond this 0.7 volt, beyond this knee point. You will find the current increase significantly, but the forward bias voltage across the diode remain to be approximately 0.7 volt. For normal operation, we would like to bias the diode in this segment so it can provide large current. Let's continue our experiment. Now we are going to do reverse bias. These two leads connecting to the external power supply are swapped, and the two probes here also swapped. Initially, we will try to set this reverse bias voltage to be quite large, but not larger than the breakdown voltage of the PN junction. Let's say that is 50 volt. Since the voltage drop across the current meter is insignificant, so it's like one wire directly connect to the cathode and the wire directly connect to the anode. So the V bias, this voltage, is essentially the same as this VR across the diode. So since V bias is same as VR and we have set the V bias less than 50 volt, so the VR has to be less than 50 volt also. So as you can see from this meter, this reading here is opposed to the breakdown voltage 50 volt, and now the VR is this value, less than 50 volt. Since the diode is reversely biased, so the reverse bias current will be very small. This current is only carried by the minority carrier. So this figure shows you only one bar here. Continue our experiment. Now we increase the reverse biasing voltage to be larger than the breakdown voltage. Since V bias and VR are the same, so the VR also larger than the breakdown voltage. So what will happen? This reverse current will increase significantly, and then maybe go out of control and heat up the PN junction too much and damage this diode. So normally we do not operate a diode at a reverse voltage larger than the breakdown voltage. This is a graph showing the VI characteristic curve of a reverse biased diode. Take note that we have said the V bias is same as VL. When the V bias increase, the reverse biasing voltage of the external power supply increase, the VL increase accordingly. But the current, the reverse current, is still very insignificant. The unit is microampere. Okay, then we further increase the VL to beyond the value of the breakdown voltage. Until then, the current can increase, the reverse current can increase significantly. This figure shows two VI curves. This is VI curve for a forward biased diode. This VI curve is for the reverse biased diode. And take note that when forward bias, the forward biased current is in unit of milliamp, and the reverse bias current is only in unit of microampere.